welcome back, ladies and gentlemen, to another exciting adventure in the land of mathematics. Alright, today we're looking at 2.5 day 2. We're doing the zeros of polynomial functions, and you can see by the objective, we're going to do that with the aid of a graphing calculator, and then we're going to write polynomials as a product of linear factors. Linear is important, and then solve word problems involving polynomial functions. So brace yourselves, here we go. Alright, so just for finding zeros in general, if I've got a function right there. Alright, x to the fourth minus 5x to the third minus 30x squared plus 92x minus 40, of course, calculator graph that for us. And in a reasonable window right here, I get a graph looking something like this guy here. Okay, so what that does right off the bat for me is tell me a couple things. It tells me right here at -5, and of course we can verify this using the various features of the calculator. It looks to me like I've got a 0 at x equals -5. Okay, over here I've got some fractional value, and again, if I go through my various functions in the calculator, I'll see that that's a very, very messy decimal. So I'm not going to worry about him yet. I'm going to go over here and say, oh, okay, well, I get x equals very nice 2. Okay, and then I go in here, this is, 5, 6, 7 point something, so that's a very messy decimal again. So I've got my 4 zeros, but I've got 2 that are pretty nice and 2 that are equidecimals, so I'm going to have to do some work to figure out exactly what they are. Although one thing that I do actually see them on the graph lets me know that they're not imaginary. So if I have an I show up in my work, I know I made a mistake. But anyway, here we go on what you would have to do. Okay. Just like the by hand method, you have to guess at what your zeros are by doing all those various tests and things. But here, taking off the calculator, we can say, oh, I've got a 0 at -5. So we can take -5 and synthetically divide it out of our original. So just putting our synthetic division together here. Okay, and again, I'm expecting to see a 0 there. If I don't see a 0 there, I know something went wrong. So going with this, I get my -5, gives me a -10, gives me a positive 50. Okay, now it gives me a positive 20. Multiplying by 5 gives me a -100. Adding here gives me a -8. And then multiplying gives me a positive 40, so I do get the 0 I was expecting. Alright, from there, again, I've got a depressed polynomial. He's a little bit sad. But now I can go with this and now divide out the 2, the other 0. And now I've got a 1, gives me a 2, gives me a -8, gives me a -16, positive 4, and then it gives me a positive 8, and again it gives me another 0 that I was expecting. Okay, and at that point, of course, now I'm looking at x squared minus 8x plus 4 equals 0, again, thinking about finding zeros, and then I can use whatever methods are necessary to do that, and for space concerns, we're going to move on. Alright, so now we're sitting at x squared minus 8x plus 4 equals 0. Again, we had those 2 zeros that we found originally. And from here, we just use whatever means are necessary to get to here, the other 2 zeros. And, okay, looking at this, I might think factoring, but I can't break up a 4 and make an 8 very well, so I'm forced to either complete the square or use the quadratic formula. A few of you are good at completing the square, so go ahead and do that, but I notice most folks seem to prefer the quadratic formula here. So we got -8 plus or minus, etc. -8 squared minus 4 times 1 times 4 all over 2a, so in this case 2 times 1, and realistically I trust you to complete this, so eventually you should end up with 4 plus or minus 2 root 3. Okay, so now our complete list of zeros, if we kind of put these things together, is -5, 2, and then 4 plus or minus 2 root 3. Okay, another part of the directions on some of the problems you're going to encounter is going to be to write this as a product of linear factors. So, product of linear factors. Okay, now again, I said this in the objective, but the linear part of the factors is important because linear means you've got x to the first. So I do need to get everything down as low as I can go for this. And also what it does is it lets me know that the original f of x, since it's a 4th power, I do need 4 individual linear parentheses to get this pulled off correctly. So, anyway, just taking our solutions now, the -5 gives me a factor of x plus 5. Okay, the x minus 2 comes from having a positive 2 as my 0. And then from there, okay, again, I've got x minus each of these 2 guys. So the x minus 4, and I'm distributing the 0, distributing the negative through the plus or minus, so it's 4 minus 2 root 3. Let me fix that. And then same basic idea, x minus, now I'm distributing a negative through the minus, so it gives me a 4 plus 2 root 3. Now this is actually one of those situations where if you messed up and forgot to distribute the negative, you'd still get the right answer. You just have them backwards of the order that somebody else might have. But anyway, there's the original function as a product of linear factors, there's the zeros of the original function, and it was nice of the calculator to help us out in that. Alright, now let's take a look at another one. Got x to the fourth minus 8x to the third plus 11x squared plus 40x minus 80. Alright, so when I graph it, again, I get something that looks pretty much like what's over here on the right. Okay, if I look at this 0 and I use my graphing calculator to find out what it is, it's negative 2 point something, very messy. And then over here it's 2 point something, again, very messy. And then over here I find this is a nice 4. Okay, now the important thing, though, about what's going on here is notice how the graph hits the axis and then takes off in the same direction. Well, what that means is we've got a multiplicity of 2 situation here. So I've got x equals 4, but I've got that multiplicity of 2 going on. And so what that means for us in terms of the synthetic division we can do is I'm putting my 4 in my box, and then 1, negative 8, etc. Alright, so I've got 1, I get my 4, negative 4 gives me a negative 16, gives me a negative 5. 5s don't like to write. I get a negative 20, get a positive 20 here, this gives me a positive 80, and again I get that 0 that I was expecting. Okay, but again, since it's a multiplicity of 2, that means I can divide it out twice. So I've got a double factor of x minus 4, so here it is. Alright, so dividing this guy out again, 1 times 4 is 4, gives me a 0. 0 over there again, negative 5. And then 4 times that negative 5 gives me a negative 20, so basically confirming that that actually works. I get a 0 there, so okay, cool. And so now what I'm looking at is x squared minus 5 equals 0. Alright, so then again, I said this was 2 point something, and well, what's going to happen in just a second? I've got x squared equals 5, and then square root in both sides, you get x equals plus or minus root 5. And of course, since root 4 is 2, root 5 is a little more than 2, so you can see visually that, hey, this thing actually plays out the way it's supposed to. Alright, so again, our complete list of zeros now is x equals 4, and again, probably a good idea to throw some kind of notation about multiplicity of 2 down there. And then we've got our plus or minus root 5. Right, so there's that. Of course, then if you want to write this guy as a product of linear factors, we've got f of x equals x minus 4. Okay, you can either then write another x minus 4 or just simply put that as a square. I would accept it either way. And then we've got x minus root 5, which is again from the plus case of this, and then x plus root 5, which comes from the minus root 5. And now there's those. Hopefully that made a little bit of sense. Alrighty, let's take a look at another one that's a 5th degree polynomial. Alright, so I've got my polynomial right here, and again, as soon as I see that 5th degree, I should be thinking, okay, I'm going to have 5 zeros. Alright, now I look over my graph once I graph it, and I only actually see 1 visually, so I'm maybe in panic mode right now thinking I mistyped something, but actually I didn't mistype anything here. Alright, the 1 0 that I see, I can use my various calculator functions and figure out that's exactly x equals 3 for my 0. Okay, but what's not obvious from what the calculator at least says to you, what you actually be able to do is interpret what you see, is notice how the graph kind of comes up, flattens out, and then takes off again. Okay, what's happening here is, well, you know, when you had a multiplicity of 2, it kind of made a parabola on the graph. When you had a multiplicity of 1, it just passes straight through, kind of like a line almost. Well, because this guy wiggles through very much like a cubic, what that's telling you is that you actually have a multiplicity of 3 on that particular 0. Okay, so then synthetically dividing, I can divide out the 3, 1, negative 9, etc. Alright, and, okay, it is kind of a coincidence that the 0 is 3 and it's a multiplicity of 3. Of course, that won't always happen. But I can take that 0 of 3, and as I do my synthetic division here, okay, I'll be able to divide it out 2 more times. So basically, you just have a whole lot of work off of one number. Okay, so as I go through this, hopefully I don't make any mistakes here. This gives me a negative 12, a negative 36, positive 18, gives me a positive 54, and again the 0 that I was expecting. But now, again, he's a triple, so I can divide him out yet again. And actually, once I'm done with this one, I'll be able to divide him out again. So I get a negative 3, that gives me a negative 9, positive 2, positive 6, negative 6, negative 18, and again, as expected, I get that 0. And then he was a triple, so one more time, and again, it's as soon as I get the 0, I'm confirming that I actually was right with what I was thinking. If I didn't get a 0 there, either I misinterpreted the graph or I made a calculation mistake in my work here. So anyway, I get a 3, gives me a 0, 0 gives me a 2, and then that gives me a 6, and again, as expected, I got 3 successfully synthetically divided out 3 times. Okay, and again, what I'm left with now is x squared plus 2 equals 0, which again we can solve in just a couple quick steps. X squared equals negative 2. Okay, and notice I'm going to get an I here, and again that I is representative of the fact that I couldn't see that 0 on the graph. Okay, it's imaginary, it means you can't see it. So x equals plus or minus I root 2 as 2 zeros, and then 3 times of the other one. So again, my exhaustive list of zeros is x equals 3 multiplicity of 3, and then plus or minus I root 2. And again, if I was so inclined to write this as a polynomial factored into linear factors, I'm going to have x minus 3 cubed, and then x plus I root 2, and x minus I root 2 as my complete factorization of that polynomial. Alright, now I'm sure you realize in the objective I mentioned word problems, so here's one. Alright, I did steal this one out of the book, but here we go. Okay, I've got a rectangular box, it's going to be mailed, and it's got this basic diagram that goes with it, and can have a maximum combined length and girth. And girth just means a perimeter of a cross section. So basically, if you just kind of take a look at the bottom or the top of the box, or cut it in half, you can see what a cross section would be. But anyway, that should be 120 inches for this problem. And so I need to now show, as part A, is that the volume of the package is this expression here. Well, okay, so basically there's what my final result should look like, but the work getting there is actually your answer. So, well, of course, the volume of any sort of box is going to be length times width times height. Okay, so in our scenario, okay, again, notice these are labeled x's here, so that x actually transfers to all of the kind of short dimensions of our box here. Okay, so basically my volume is, and I don't care how you kind of put it together, but between the length, the width, and the height, 2 of those are x's, and then 1 of them is going to be a y. Okay, but again, I want this to be just in terms of x, so I need to do something to eliminate the y and turn it into something that has an x in it. Okay, well, what we can do there is use that statement about the length and the girth has got to be 120. So the 120 has got to be the length, y, plus the girth, and the girth again is a cross section, and we're talking perimeter. So of course perimeter, you just add all 4 of them up. So I've got 4 x's going around here, so well, that's exactly what you put there. Okay, and a little bit of manipulation here gets me y equals 120 minus 4x. So now I can take that, plug it back into my volume expression here, and I've got volume equals x squared times 120 minus 4x. Now getting to the desired answer, it's not too much of a stretch. Basically just write this guy as function notation, and then again, if I can factor out a 4 here, the 4 comes out, meets up with the x squared, and then I've got left over 30 minus x. Alright, and again, showing that's true, it's kind of like a proof in geometry that the final answer isn't your last line, the final answer is the entirety of the work. So basically all of this plus all of this is the proof that that's actually my volume. Alright, now once we've got the volume figured out, okay, we can go on and answer some other questions about it. Alright, so part B of this is going to ask us to graph the function and determine the dimensions will yield a maximum volume. And my personal little note on this, I'd be sure to consider the domain. Okay, because if you're looking at the volume function here, and you think about if I were to simplify it, I'd end up with a negative x to the third. Okay, so I'd have my upside down barrel of monkeys thing, and you can kind of see that on the graph here that I've got, where it would come down here and then take off kind of toward positive infinity. So if you're just doing that and thinking maximum, well, you think, oh, well, it's infinity. But the domain in this situation, okay, again, I'm going to have from 0 to 30 basically is my only possibilities as legitimate x values. Otherwise I'll end up with negatives in places I don't want them. So that's why my graph here goes from 0 to 30. And so now to find the maximum volume, okay, I'm looking for that maximum point right there within our domain, because remember the y is our volume, so I want the biggest y I got, and there it is. Okay, so anyway, using the various functions of my calculator, I can figure out that that's the point 20, comma 16,000. Alright, so the 16,000 is the volume that they actually don't ask for, but there it is in case you needed it. But the number we actually need is the 20, because that's our x. Okay, and if you remember, the x was 2 different dimensions of our box. So our box is going to be 20 by 20 by something else. That something else, we can use that y formula we used earlier to get the volume formula, which was 120 minus 4x. And in case, if forgot. This is a 20 for the x. And so 120 minus 80 gives me a 40. So my box is 20 by 20 by 40. That will give me the largest volume possible. Alright, then for part C, the book asks this in kind of a weird way, I think. They kind of make you do one where you have to pay attention to the domain first, and then they kind of ask you one where you don't pay attention to the domain. But anyway, the book's doing it, so I'm going to do it in the same way, just so that you're prepared when you see it. Ignoring the domain, what values of x will yield a volume of 13,500 cubic inches? Alright, so basically what I did here is I kind of manipulated my equation around and got it as 13,500 equals the 4x squared, 4x squared times 30 minus x, and then from there brought the 13,500 to the other side, so I was looking at 0 equals 4x squared times 30 minus x minus 13,500. And if you're looking at that going, why don't you FOIL it out or distribute or anything like that? Well, you know, the calculator doesn't care if you do or not, so I didn't either. Alright, so what's going on now though is after I get this graphed, okay, I can look at this thing and I can see three different, zeros. I can see this guy over here, and using the various intercept or zero functions of my calculator, that guy works out to be negative 9.27. Over here, this guy's dead on 15, and then this guy worked out to be about 24.27. Alright, so ignoring the domain, what value of x will yield the volume of that? Well, those three values are the negative 9.27, 15, and then 24.27. But realistically, and I think it's almost even silly to circle those as a final answer, because at least one of those guys is complete utter garbage. Second part of the question, which values are a physical impossibility? The negative 9.27, obviously, since that's supposed to be a dimension of a box, you can't have that. And then you look at these other two and say, hey, do they work? Well, they actually both do, because if you remember our domain from earlier, our domain goes from 0 to 30. Alright, so as long as those guys fall underneath 30 and above 0, they're good. So part 2 of the question is the negative 9.27 is bad, and then legitimately the only dimensions we could use are the 15 and the 24 and change. Alright, taking a look at another word problem, also stolen from the book very craftily by me. Got a company making bikes and estimating its profit by this model. Again, we're given a domain to work with, and X is the advertising expense in tens of thousands of dollars. Okay, of course, the more you advertise, in general, the more you make, but if you throw too much money at it, you're just wasting money. But anyway, here we go. So we're one of the smaller the two amounts will yield a profit of 800,000 bucks. Okay, well, I've got a graph here, but I don't actually have the equation that's graphed yet, because I've got this 800,000 I want my profit to be. Okay, so there's my 800,000, and I want that to be my profit, so now that's equal to my profit expression. Alright. Okay, so now to have something to graph that I can find the zeros of, again, I just have to take the 800,000 subtracted from both sides and get myself a 0. So I get a new equation that looks pretty similar to what we just had, but now the 275,000 minus 800,000 actually gives me 1,075,000. Okay. And so now graphing that actually gives me the graph you see to the right. Okay, so now what the question is actually asking us to do is find the smaller of the two amounts that will yield a profit of 800,000, and that's what I'm looking at here. And so again, since I'm doing this, I'm finding the zeros, since I set my equation equal to 0, so I've got a value here and a value here, but again, I don't care about that one, the one that's a little bit over 40, because they asked for the smaller one. And again, using the various features of my calculator, I can find that that value doesn't come out exact, but it comes out to be 31.5379, kind of a messy number. Alright, so if your boss asks you how much you spend on advertising, right now if you tell them $31.50, you're going to get fired. Because remember, this is in tens of thousands of dollars. Okay, so basically, you have to multiply that by 10,000. Alright, so the value that we're looking for is actually 315,000, and depending on how we're going to round this, we could actually either be very precise at 379, or if the directions were something a little bit differently, if you just said like 315,000, depending on the degree of accuracy we're looking for, then that might be good enough. But anyway, that's what you got to do to figure out something along those lines. And as per usual, here's the assignment. Nothing too much to say about it. It's going to play out very much like the notes I just gave were. So there you go, and I'll see you in class.